Alright, hello and welcome back to my real-time strategy in Unity tutorial. Today we're going to be expanding upon the location finding algorithm for buildings we did last time, and sort of working in with AI so that we can have builders build buildings at those locations that we found. So I'll just give you a quick demo here. So if I press I, it will let us get, these AI workers will start building a building. And then they will move on to the next building. There's 4 buildings in total that I've got in the game at the moment, so they'll build one of each. This doesn't cover like AI gathering resources or anything. I'm going to develop this over time, so we'll have components of the AI. So say we wanted to build buildings, we want to go gather resources, and then we'll have say like build building. If we can build a building and we have enough resources, we'll do that, but if not, we'll switch to gathering resources until we have that much sufficient resources. And so slowly build up the AI piece by piece, so we're not like getting in over our heads or something. Also, I added a farm because there wasn't a way for food to be placed in the game, which was a bit of a mistake on my part. Sorry, but it's here now. What else? There have also been a couple of changes, which I will go over in the code description. So yeah. Okay, so first off, I'm just going to go over the changes I made to existing code. So one thing, I added the farm, obviously. So I've got, first off with variables, we've got a building, which is just this building, which is fine. Second is the public game object. This is the wheat tile. So if we look in the inspector, farm, it's just there. So it's just the normal wheat tile. So see, wheat tile. And what that does is if the game object is true, so if the object is active in the hierarchy, so if the building has been built and placed in the world and it's not just this prefab that we have for the farm, then it will check, it'll call this is building built method. And if the building is built, so its health is more than or equal to 100, it will get an area of the grid, 12 by 12 surrounding the farm building. And these bits of code here are just to make sure that the grid fits in the dimensions. So if it is either more than the grid dimensions or on either the X or Y, or is less than 0 when you add the +6 and -6 to the position of the farm, then it will sort of round that to the edge of the game world. So it'll be either 0 or 249, I believe, because I'm using 250 by 250 grid. And yeah, and then what it does with that is it uses these as references. It uses the get tiles method from the grid generator, and it goes through this list of tiles it gets, and for each of them, it will switch out the tile with a wheat tile if the tile is not rocky, is not a mountain, is not water, and is walkable. So that's basically just to make sure that all 3 of the conditions are met. To make sure that it's like a valid place for farm to be, because you can't have like farm on mountains unless you're the Incans, but whatever. Yeah, and then it just destroys it because we've done it once, we don't need to do it anymore. And the change tiles in grid method is a new overload of the existing method, because I wanted just one method that would change. I could do a 1-for-1 switch in tiles. So what it does, it's identical to the one that takes a list, but this way you can pass in a new tile if it's not like the player manually selecting tiles and changing them for whatever current tile is selected, like I did. Christ, it must have been ages ago, that one, but yeah. So this basically just gets passed in a tile and passed in the tile that you want to change. It will find that tile's position in the grid using the grid coordinates that are in the tile master class. It will store values like if the tile is walkable, its pathfinding node, and the old game object, and then it'll destroy it, so it gets rid of the old game object because we no longer need it. Then it creates a new tile at that position, and then this goes about setting all its values. So here we have it setting the grid coordinates back to the original values, to the transform.parent. So it'd be part of the, setting if it's walkable or not, setting the pathfinding node, and setting it back to its position in the grid of tiles. And then finally it sets it to being active. It's basically identical, but it doesn't cycle through the list. And also I made a small change to the change tiles and grid, if you were still using that. Basically, I just had to add in the condition for setting the pathfinding node when they were switching a tile round. So yeah, that was that. That was all for the farm. Also, I forgot to mention, each wheat tile now has on the wheat resource script. Sorry, I believe I implemented it before, but I didn't have anything in it. On its await function, it basically just adds the game object of the wheat to the list to the resource store list of food tiles, just so like AI would be able to find food that's near them. I just forgot to add that in. There were also a couple of patches I needed to do for the building script to get rid of a few errors. First off was when the AI was creating a building, it sometimes wouldn't be able to find the get go to tile. So basically, I had on the which is the go to tile is basically a tile that is below the building that has been constructed. In order to say it would be where the units go to when they want to build it, or say if you were trying to spawn a unit, the unit would be spawned there. And sometimes that wouldn't get assigned when the AI is placing a building. So what it does is if it checks if it's null first, and if it does, it will set the tile near the building location based on the current transform, the position of the building in the world, and that just basically calls it here with the tile at the sort of center of the building's position, roughly. And then that'll assign the building's tile near me, and then we can return it. Otherwise, if the tile's already been assigned, then it's fine, we just return it normally. The second is, for some reason, it wasn't getting, the building sprite renderer wasn't being assigned. I'm not sure why, but just to get around this problem, I have a check here in the increased building health. So each time a worker is in the process of building it and the timer gets to 0, it will call this increased building health method to make the building health increase and increase the alpha channel if it's not already been built. So what this does is it just checks that it actually has a sprite renderer, so we don't get a null reference exception when trying to do this, which is okay. Okay. I also added a get building method, which takes a string, which is just the name of the building. And what this does is it'll go through all the buildings that could potentially be built, which are stored in this building store, not the AI building store, which is the buildings for a specific faction, but this is more of a general thing that stores all the buildings that could possibly be built and the players' buildings. What this has done is it's used by the AI just to grab buildings when it wants to build them. So basically, it looks for a building with a particular name. So you could pass in farm, barracks, temple, whatever. It'd go through the list and return the building that matches the name. And if it doesn't return anything, it returns null. I just needed that to use for the AI. So that was a quick fix for that. Also, just one more quick temporary fix. Occasionally, paths would return a path that was just a length of 1 because for some reason that they just wouldn't find it. I believe it's due to units being stuck on a unwalkable node, and then the AI can't, or the pathfinding algorithm can't find a way off that node, so it just leaves it there and returns a list of length 1. To get around that, until I find a more permanent, better solution, I've implemented this, so it checks if the current path is less than or equal to 1 in length, so it normally just return the final location. It will basically just move it in a straight line between the final location and it'll just move the unit in a straight line to the final location without using any of the pathfinding. And once we get within 1 meter, unit, whatever, of the final location, we set our movement to false, which will basically let the unit do something else. One issue, it uses this public vector 3, which is the final location, which is assigned when we tell the unit to move to a position, just in case we can't find a path. So so that will be fixed in an upcoming part, but I just wanted to make you aware of the fix that I had currently implemented, and if it does get a path, it just works like normal, so it'll just move along the path, as it should. Okay, so first off, we've got a new addition to the faction script for this AI decisions that we're implementing. We've got a new script called an AI decision maker that we basically just initialize in the initialize function of the faction script. So it's added, the component is added there, and then it is got and stored, and that's pretty much it. So now onto the decision maker itself. Basically, what this is going to serve as a base, so it'll be where the AI makes its decisions on what to do. So say if it needs resources, or it needs to build a building, build units, or whatever it wants to do, it will make the decisions here, and we'll expand over on this on the next couple of episodes to add more functionality to it. But for the time being, what it does is basically just got a decision queue, which is a list of this new script of decisions that I've created, which I'll show you in a minute. That it's basically, we'll look at this decision and perform an action that is stored there based on it, and then remove it from the queue. And in this case, we've got one example decision called build building. So we pass in a string building. So this would be farm, temple, barracks, the type basically. It will add the component decision build building to the script, initialize it with the respective variables. So the faction that the building is being built for, and the building script. And we'll also set the faction again, apparently. And we will then add it to the decision queue. And once this queue is when this queue is more than 0 in length, so there's an action in it, it will call the do action method and then remove it from the script, from the queue. Sorry. So let's have a look at how the decisions work. Okay, so first off, we've got a base decision class, which all our more advanced decisions are going to inherit from. It's got a couple of variables, and so it's got a priority. So in the future, I'm envisioning that each time an action is done in the queue, the AI will sort of like look ahead through the rest of the queue items and try and determine which is more important. So say if we desperately needed resources, or we were under attack and needed more units or something, then the AI would make these decisions a higher priority than, say, just building another building or something. So that is what the priority will be used for in the future. Again, we've got a faction identifier, so we have a quick reference back to the factions, so we can access things like buildings, resources, and units. Got a setter for the faction identifier. We've got a virtual boolean, can we perform action? So in the future, we might have some kind of resource check, or do we have an upgrade, or do we have enough units, or, whatever. We've got a do action. Again, this is overridden with what we need to do to complete the action. And we also have a virtual void on can't perform action, which in the future will be like, okay, so say we failed the can we perform action because we didn't have enough resources. In response to this, we might say, all right, go and find free workers and then and tell them to go gather more wood and stone or gold or whatever. And I've got my one example of the where is it? Decision build building. One example of it here. So this gets initialized with the faction identifier and the string of the building type. And so this basically just initializes variables. And basically we're not adding resource checking just yet, because we've not got a way to gather resources, so that'll be done maybe next episode. An undo action. So if we can perform the action, we get the building of the type, so farm or whatever. We grab the building script and we use the faction identifier that we saw in the parent class. So I see the faction my faction here, and we can see we inherit it here, decision here, so that we can use the my faction which is assigned here. So we use this as a quick reference to the my building script, and then we add the job to construction queue, which is my faction, which basically, if you remember last time, we had it basically added a construction queue job which got a location for the building. So it uses the faction spawn location as a starting point, and we pass in the building that we had to build. Because I've changed it from using the random width and height to using the actual buildings. So from that AI decision to build a building, we pass in the position in the world, which is the spawn point of the faction, and the building we want to build. And we create a new, don't need that debug.log, construction job store, which, as we did last time, or I showed you last time, was basically a store for the width and height of the building we wanted to do and what workers we wanted to assign to the job. So it basically creates a new one of them, and this has been changed slightly differently. So now we are actually using the building's information rather than the random width and height. So on the construction, we pass in a location to build a building to build, and a list of workers that we need. At the moment, we are not going to be using we've not got a list of workers with a job versus workers without a job. So right now we are just passing in all the workers regardless of what they're doing. So that'll be something we do in the future. Where's the building store? Yeah, my faction issue the workers. Yeah, so that's the third item in there. And then again, I showed you last time, but I'll just quickly go over it again. We have a construction job queue, which is monitored, checked each frame. If we've got a job in it, and if we're not already if you've not got a threaded building location, fine. So if we're not already searching for a building location, we will create a building which creates a thread that looks through the entire game world and tries to find a location near to our spawn location that is the correct size and has an adequate area around it to allow units to navigate around it when it's being constructed. And once it's finished, if you need more information on this threaded building location find, you can go and watch the last episode. Once we've got to the end of this thread, if we couldn't find a location, it will just basically say we're not waiting for a location, and it will create the next building. And otherwise, if we have found enough of enough tiles to build it on, then we say we're not waiting for a location anymore. We set all these tiles to false, to not be walkable, sorry. And then we call this create next building method as well. Now on create next building, we basically check if we have more than 0 tiles. So if we have 0 tiles, it basically means we couldn't find an area. So we just remove that job and try the next one, and so on, so on. But if we do have more than 0 tiles, so we have found a location to build it, we call this create building method, which basically just uses the building in the my jobs list, so the first one. So to build.gameObject, it'll instantiate a new instance of M at just 0, 0, 0, because we don't need the position for the time being, and rotation of 0, 0, 0, obviously. Set the game object to be active. We add a sprite renderer to represent the sprite. We set the sorting order to 10 just to make sure it's above all the resources and stuff. And then we set the sprite to be whatever the building sprite is. So if I just show you in the inspector, we've got so these are what will be instantiated. So say it will instantiate the temple, which will just have this script on and nothing else, and then it will grab this building sprite, and yeah, and use that as the building sprite. And then even for the construction job store, it'll use these width and height in tiles to determine the area rather than just using a random width and height like I did before, just to demonstrate it. And then it will set the color to be white but with a really low alpha value so that it's transparent, and will get progressively less transparent as the building is progressively more built. And then we add a glider. We still need to add the faction identifier, I believe. I don't know. Actually, no, I have done that. Sorry. That shouldn't be there. I did it somewhere else. Yeah, and then we return that building that we've built. So once we got that building, we have to work out the position that we want to place it based on this grid of tiles that we have found through the thread. So thanks to how it works, so basically we go from left to right in the grid working. So say it'd be 1, 2, 3, 4, 5. That'd be one row. 1, 2, 3, 4, 5. One row. 1, 2, 3, 4, 5. And that'd be the third row. So what this allows us to do is we can assume that the first tile on the list will be this one, and the last tile on the list will be this one. So we can find a center point through this equation here. So from the first tile in the position plus the last. Oh, sorry. So first off, we take the tiles in the thread, the last tile in the list's position from the first tile in the thread's position, and divide it by 2, and that gives us like the distance between them. And then we add that to the original position, which gives us the midpoint in the grid of tiles that we just found. And that is where we will place the building. This line of code here. And then for each of the workers that we wanted to use to do the job, we add an AI building script, and then we initialize the target with the G game objects we just created and move to the position. And then we add the new build script to the unit master class worker decision queue. So it'll go do that job, and then we remove it from the list of buildings to create. So yeah, we do have one slight change. We do have an AI building script, which is essentially the same as the building action for players workers, except with one difference being that we have a check here. So on is action complete? So if the action is complete, so the building's been built, and if the building doesn't already have a faction identifier on it, then we add one and assign it to be the faction of the worker that's building it. So that'll, again, we use these faction identifiers as a quick reference to all the faction scripts and as a way of distinguishing which building belongs to which faction, which unit belongs to which faction, stuff like that, without having to cycle through a massive list of workers. Not workers, just objects. And then if it's not already been added to the list of buildings for that faction, it's added. And that then returns true. Okay, so I'll just give you a quick demo of it working again. So again, this episode, we made it so that the AI workers will go around building buildings at the locations that we found using the code we wrote in the last episode. I'll just show you, so see how they're going to be just walking around. They'll build buildings, and these buildings will then get added to the building queue. So in future episodes, we can reference them and say, all right, we're going to use that building to build workers because it's not actually doing anything. And we want to build another farm because we've not got enough wheat or whatever, stuff like that. So yeah, I'll just give you a quick demo. So that's pretty much it. Like, comment, subscribe, all that shit. Go play Loud or Quiet. I've been working on that. I'm adding a new arcade mode, which will be closer to the web version, but with more free roaming environment and stuff. So hopefully that turns out good. We're doing some more sprite work on it as well, so it looks a bit prettier. What else? I'm almost at the end of my degree, which is kind of scary. I've got 2 weeks. No, 3 weeks. 3 weeks today, and I will be done. Which is kind of scary. No, it's 2 weeks. Next week. Yeah, it's 2 weeks, sorry. It's kind of scary. So if you want to subscribe and encourage me, now will be a good time so I don't get a proper job. But yeah, again, a MakerStation that's on itch.io as well. It's like a prototype for my dissertation that I created. It's like a procedurally generated roguelike 2D shooter kind of thing. If that is something you'd like me to continue or make some kind of tutorial on, then I will be more than happy to do that at some point. Would like to finish Loud or Quiet by the end of this year. But yeah. Again, any ideas for tutorials? I was thinking of actually my next tutorial being of a pathfinding tool. So you know how like you have the A-Star pathfinding project? There were some features in that I would like to see, so I might have a go at doing that myself. So yeah, just watching. Bye.